This is a video going over some review problems from the review day for Unit 1 in Calculus. Okay, so first thing is some domain problems. So find the domain of the following. So I'm trying to give you kind of the various types here. So we've got 3x over x squared minus x minus 6. That's one. A second one is g of x equals the square root of 2 minus x. And a third one here is h of x equals 5 over the square root of x minus 3. So I would suggest pausing it to try it yourself first and then coming back and listening to my explanation. Okay, so now going through these problems. So for domain, the thing we most concern ourselves with that we're looking for is denominator can't be 0, and under a square root, it has to be 0 or positive. So in number 1, the thing that concerns us is this denominator cannot be 0. So we need to figure out, well, where would it be 0? Because that's what it can't be. And so we find after we factor, it can't be 3. And it can't be negative 2. And to put that into interval notation, because that's what I'll ask for, you're going to say negative infinity, negative 2, union negative 2 to 3, union 3 to infinity. And when someone looks at this, the reader looks at this, they see that it's everything except where these breaks are. So it's everything except negative 2 and 3. Whereas 2, I have no denominator, but I do have a square root. So that's when you set up an inequality, because I need inside the square root to be greater than or equal to 0, which means I need x to be less than or equal to 2. So the domain here would be negative infinity to 2 with a bracket. 3 is somewhat of a combination of 1 and 2. I have a square root, but it's in the denominator. So because the square root means I still need an inequality, but instead of saying greater than or equal to 0, I'm just going to say it has to be greater than 0, because equaling 0 would be a problem since that square root's in the denominator. So in this case, I just have x greater than 3. So the domain would be 3 to infinity, not including 3. And again, convince yourself, because if you plug in 3 for x, you would get 5 divided by 0. Again, that's problem. Okay, so that's one grouping. Now let's talk about another set of problems we could have. I could ask you to factor. So I'll give you some problems, and then again, you can pause it, and then we'll see how you did. So 3x squared plus 9x minus 30. And again, the directions aren't to solve, it's just a factor. Second one might be 4x squared minus 9y squared. A third one will be 2x cubed plus 5x squared minus 3x. And then a fourth problem to look at is 27x cubed minus 64. So when you factor, the first thing you always want to do is see, is there a GCF I can take out? Because factoring with smaller numbers is always better. So I notice in 1, I can take out a 3. And when I do that, I get x squared plus 3x minus 10. And this factors, I've got x and x, and then a positive 5 minus 2, and that would get me a middle term of 3x. And again, no need to solve, just put it in factored form. So we're done. 2, so whenever you have a binomial, which means 2 terms, think, am I dealing with a difference of squares, which would be 2 perfect squares subtracted from each other, in which case this is the formula, or am I dealing with the sum or difference of cubes? So I'll just put up the difference one right now. And I'm going to give you these formulas, but you just have to recognize when to use them and then to actually use them. Okay, so I notice in number 2, it's the squared kind of gives it away, the x squared and the y squared. It's the difference of squares. So then I say to myself, okay, the a is going to be the square root of this first term, which would be 2x. and b is the square root of the second, so 3y. And now let's just literally put it in that formula, a plus ba minus b, so 2x plus 3y times 2x minus 3y. Okay, and then we're done with factoring that. 3, remember what I said, always look to see if I can take out a GCF. I can take out an x. So I've got 2x squared plus 5x minus 3. And the possibilities for 2x squared have to be 2x and x. And then it's just a matter of figuring out, and also for -3, I've got 3 and 1. So it's just figuring out where to put it. So if I put the -3 here and the +1 here, just eyeball if you get the correct middle term. I would get -6. Nope, I don't. I get -6x plus 1, which is a problem. I want the opposite of that. So let's just change what we have here. If I do +3, so it'd be +6x minus x. That would get me +5x. So that's better. Okay, and the last one here, binomial. 27x cubed is not a perfect square, but it is a perfect cube. So that tells me I'm going to be doing this formula here. So my a is the cube root of 27x cubed, which would be 3x, and my b is the cube root of 64, which would be 4. And now let's plug it in. The minus just tells you, don't put the minus with the 64. The minus just tells you that we're using the difference of cubes formula versus the sum of cubes formula. So the difference of cubes would be literally plugging it in the formula. And then it's a squared, so 9x squared plus 12x plus 16. And by the way, the reason this formula is the way it is, it doesn't break down any further. This is not factorable. In fact, it would produce, it's going to produce imaginary roots, so you're just going to leave it like this. Once you use that formula, you're done. Okay, so that was part 2. Now let's go to, it's related to this, which is finding zeros. So let's open up a new page. Okay, find the zeros, which are solutions, or sometimes if it's a quadratic, it's the x-intercepts. So here are the problems. So 3x squared minus 2x minus 5 equals 0. Another one is x squared minus 10x plus 1 equals 0. Plus 9, not plus 1. And let's see, maybe I only did 2 of those in class. Okay, so let's do these 2. So you could either, finding the zeros, you could either factor it or do the quadratic formula. I think this is one we just did, so it does factor. So it factors to 3x and x, and minus 5 plus 1 equals 0. So then set each factor equal to 0 and solve. So 5/3 and -1. So those are your 2 zeros. Whereas in number 2, this factors to x minus 9, x minus 1. So your 2 zeros are 9 and 1. I mean, the hardest part about finding the zeros is the factoring, which we did in the previous part. So something else somewhat related is find the intersection. So find the intersection of the following graphs. So 3x squared minus x minus 2 and y equals x plus 3. So you can try that and then come back here. You can pause this if you want and try it and then come back and see. So to find the intersection, they have to have the same x and y, meaning, so you're finding the points that are the same on both. So I'm going to set the y's equal to each other. In other words, x plus 3 equals 3x squared minus x minus 2. And how do you solve something like this? Okay, so bring to one side here. So we've got 3x squared minus 2x Minus 5 equals 0. And so this should look familiar. So we know it factors. Oh, I already put equals 0. Don't need the equals 0 twice. Okay, so this factors to 3x, x, and then we've got minus 5 plus 1. And so the two x's that are at the intersection are 5/3 and -1. You're not done though, because I'm asking for I would ask in the directions, and I should have said here, find the points of intersection, the x and the y. And so when x is 5/3, you could plug it into either equation, but plug it into the easier one. So if I do 5/3 plus 3, then we would get a y coordinate of 9 plus 14/3. If we plug -1 into y plus 3, we get 2. So those are your 2 points of intersection. Okay. Now let's move on to something else we talked about with our review of the algebra is simplifying using some exponents, simplifying with exponents. So let me do a new page here. So simplify, and your answer should have no negative exponents. I'm abbreviating directions here, obviously. Okay, so I'm going to put down 2 types of problems. If we have 9x to the -2, y to the 3rd, divided by 15x to the -4, y to the -1. And then the second problem would be, let's see, what do I want to do for the second problem? Let's do something like this. X to the -1/3 times 64x to the, let's see, 64x to the, I'm trying to think what I want to do here, to the 2/3 over 4x. Okay, sorry about that. All right, so now see if you can do that, and then I'll go over them. All right, so remember what negative exponent means. It means 1 over. So when I have a fraction, I just want to switch the floors they're on. So in other words, the numbers just have exponents of 1, but the x to the -4 comes up as x to the 4th. The x to the -2 goes down as x squared. The y cubed stays, and the y to the -1 comes up as y to the 1. You can put if you want. All right, now let's simplify everything. In fact, the numbers simplify by 3. So I've got 3 on the top, and then x squared goes into x to the 4th. Remember, same base, you subtract exponents, so I'll have an x squared on top. And then I've got y to the 4th on top when I combine the y's. When you multiply, you add the exponents, and there's just a 5 left in the denominator. All right, and now the next one here, a little bit more complex. All right, so here, so everything inside these parentheses, 64x, is raised to the 2/3. So let's actually just write that out. So I've got times 64 to the 2/3 times x to the 2/3 over 4x. I actually can combine these x's because remember with the same base, you add the exponents. Oh, wait a second. In fact, I think in class, well, actually, doesn't matter. In class, I had made it x to the 1/3, I believe, but that's okay. We'll just deal with it as is here. Okay, so same base, you add exponents. So it'd be x to the 2/3 plus a -1/3, which would be x to the 1/3. And then remember what fractional exponents mean. This means, when I'm dealing with this number, this means the cube root of 64 and then square it. Well, the cube root of 64 is 4, and then squared will be 16. And then in the denominator, I have 4x. Okay, so I can reduce things. 4 goes into 16 4 times. And then I've got x to the 1/3 and x to the 1. So in the denominator, that will be x to the 2/3. And you can just leave it like that. Okay, so that was simplifying exponents. Now let's move on to, let's do a problem involving the difference quotient. All right, so I'm gonna make a new page here. So let's say let f of x equal 2x squared, minus x minus 3. First question is going to be find f of x plus 2 and simplify. And the second question is find the difference quotient, which is f of x plus h minus f of x over h, and simplify. Okay, so I'll go over this, and you can pause if you want to do it. All right, f of x plus 2, it means wherever there's an x in the function, you put x plus 2. So it's going to be 2x plus 2 squared minus x plus 2 minus 3. And then it's just a matter of cleaning it up. 2 times x squared plus 4x plus 4 minus x minus 2 minus 3. Or I've got 2x squared plus 8x plus 8 minus x minus 2 minus 3. Sorry, running out of room, which finally is going to be, if I combine like terms, I've got 2x squared plus 7x plus 3. That's how that simplifies. Okay, similar idea here, except a little bit more abstract because it's just x plus h, some more variables. So f of x plus h means wherever there's an x, I'm putting x plus h. So it's very similar to when I put x plus 2. And then from that, I'm subtracting the function itself, so minus f of x. And I'm dividing this whole thing by h. So then it just becomes a matter of cleaning this up. So simplifying, that is. So I've got 2 times x squared plus 2hx plus h squared minus x minus h minus 3 minus 2x squared plus x plus 3 all over h. And remember, once we're done simplifying the numerator, a good indication that you've done it correctly would be that the h in the denominator cancels. So 2h squared minus x minus h minus 3 minus 2x squared plus x plus 3 all over h. Okay, so hopefully some stuff cancels up here. And it looks like the 2x squared goes away, which is good. Negative x goes away, and the negative 3 and 3. So I'm left with 4hx plus 2h squared minus h over h. And if I factor out an h from the numerator, then that will cancel with the h in the denominator. So we're left with 4x plus 2h minus 1. Okay, great. So just a few more problems. Let's do, see if I can do something similar to what I did in class about compositions. So let's do actually I want to use white here. Let's say let f of x equal 3 over x, and g of x is going to be, let's see, what do I want g of x to be? 1 over x minus 1. I think that's very similar, if not exactly what I did in class. So the question is find f of g of x and simplify. We'll do that first. And then the second one will be going the other way. Find g of x, or the other composition, g of f of x, and simplify. Okay, so what this means is I'm plugging into the f function for x this g function. So wherever there's an x in the f function, I'm plugging in 1 over x minus 1. I can't leave it like that because that's a complex fraction. But 3 divided by a fraction is the same as 3 times the reciprocal of the denominator. So it's 3 times x minus 1 over 1, which is just going to be 3x minus 3. So that one was pretty good. All right, this one is a little bit more involved, but not too much. So g of 3 over x. That's my f, and I'm gonna say 1 over 3 over x minus 1. Again, a complex fraction, but instead of having just single fraction in the denominator, I have 2 terms. So I think the best strategy there is to multiply the whole numerator and the whole denominator by the least common denominator. So in this case, that would be x, since that's the only denominator out there. So this would be x over 3 minus x. So it's just cleaning it up so you don't have a complex fraction in the denominator. Okay, so the final problem, and I'll give you it, that I want to do is a compound interest problem. I will give you the formula, which is the following. A equals P 1 plus R over N to the NT. You just have to know what the different parts mean and how to actually use it. So say I said you deposit $5,000 in an account with annual rate of 3.5%, compounded an annual rate of compounded monthly. How much will you have after 10 years? Okay, so to do this, you're finding the end amount, you're putting in your principal or your initial amount is 5,000. You always put in the annual rate as a decimal, so 0.035. N stands for the number of times compounded per year. And then T, so you've got 12 for N, and then T is the number of years. And then if you plug that into your calculator, you should get 7,091 and about 7.24 or 72 cents. Okay, so hopefully that is helpful. Those are the problems that we went through during our review day.